we burn over 4 million gallons of fuel a day. That represents about 2.2% of the entire consumption of fuel in the United States, as well as 30% of our total operating costs on the railroad.
Burlington Northern Santa Fe, one of America's largest rail freight companies, has 6,300 locomotives hauling 220,000 freight cars. On any given day, BNSF is the single largest consumer of petroleum-based fuels in the world, surpassed only by the U.S. Navy during wartime. But that's something they're looking to change.
At Burlington Northern Santa Fe, we are committed to our environmental stewardship. As one of the largest Class I railroads in the nation, we take it very seriously.
They take it so seriously that BNSF has now committed itself to building the locomotive of the future. A locomotive powered by a fuel which will never run out: hydrogen.
Hydrogen is inexhaustible as a fuel. Hydrogen is the most abundant element in the universe, by far. It's made up of only two fundamental particles, a proton and an electron.
Arnold Miller of Vehicle Projects is teaming up with BNSF to try to power a train with nothing more than hydrogen. Because hydrogen is so simple and so abundant, it's considered a universal fuel, which can be extracted from ordinary water. Their design calls for replacing the train's enormous engine with a much smaller and cleaner fuel cell.
A fuel cell is a power device analogous to an engine. The input is chemical energy of fuel, and the output is electrical power.
A hydrogen fuel cell is a device which turns hydrogen into electricity. Hydrogen atoms stored in the cell interact with oxygen from the air. The result? Electrons are stripped from the hydrogen, creating electricity. The only byproduct is H2O, water. And at least in theory, a fuel cell is twice as efficient as an internal combustion engine.
In today's environment, the railroad can move a ton of product 430 miles on a gallon of diesel fuel. If you translate that into what we can do with hydrogen, it would make a tremendous impact on our ability to ship product.
Eco-scientists are still trying to work out ways to efficiently manufacture and store large amounts of hydrogen for fuel cells. But at Burlington Northern Santa Fe, they're betting on a vision of freight trains that are clean and green.
What's so exciting about this project is that even though this project is in its infancy, one can only imagine the potential and the possibilities of this type of technology.
Trains will revolutionize our global transportation infrastructure because they'll be fast, safe, convenient, and sustainable. And sustainable trains will be trains powered by hydrogen. But so far, our future trains are facing a slowdown because getting hydrogen from water is proving to be difficult and expensive. Bruce Logan is a garbage man, and he may have a better way.
There's a lot of energy in organic matter, and that's why bacteria eat it and break it down. But when we make hydrogen in the process, we can capture about 80 to 90% of that energy as hydrogen gas.
Okay, Bruce Logan isn't really a garbage man. He's an environmental engineer, and he sees future trains powered by hydrogen that comes from waste.
When we say waste, we mean anything that's biodegradable that's not being used for another purpose. So, for example, wastewater from humans. It could be animal wastewaters. It could be a food processing wastewater. It could be food that was not eaten by people. Virtually anything that's biodegradable.
And believe it or not, this slop could be what runs future trains.
We realized that to develop any sort of sustainable transportation infrastructure, we're going to have to capture energy from waste sources and using that for useful purposes.
To turn waste into fuel for trains, Professor Logan has developed a very unusual power station, a microbial electrolysis cell. Inside the cell, bacteria live and breathe, and in the process, produce hydrogen.
The key is to not let bacteria have oxygen. we put them in a device which keeps them separated from that oxygen, so these electrons flow along a circuit making current or electricity.
In the absence of oxygen, bacteria living in Logan's device release protons and electrons. When a small jolt of electricity is added, these particles fuse into a usable hydrogen gas. The combination of waste and bacteria to produce hydrogen could re-energize the railroads. Today, trains rely on oil wells and coal mines for fuel. Someday, they'll rely on farms and sewage plants for hydrogen.
What are trains going to do when they cross the large distances of the Midwest? They're going to need to refuel. And why not refuel on material that could be generated across the country, where we could envision these towns along railroads taking the energy from crop wastes and turning it into hydrogen right there and using that hydrogen to refuel trains. Right now, we can't imagine that happening, but 100 years from now, it could be very likely.
Scooping up garbage for fuel as they go, the trains of tomorrow will hurtle across the country quietly and cleanly.